joint by pin joint.
Small query.
Yeah.
How do we as a student understand or know that the internal alignment is not correct?
Yeah, that's why I'm going to discuss it. That's why I put up this particular structure here. So, for a plain truss, if you start with a triangle, say this is a stable structure. A triangle is a stable structure, you know. Now there is a simple rule that if you put any joint and join it by two members, it will again remain stable. This is called simple plain truss. ABC was a triangle. I have put another joint D and joined it by two members, and if we go on adding like this, it will remain a simple truss, and this will be a stable structure. We can take any other point. Say I have taken E here and joined it B with D. This was the logic behind it, that ABCD was earlier a stable structure. Now since point B is fixed, I mean it is stable, point D is stable, now we are taking point E and joining it by two members, then point E will also be stable. So this is the basic logic. So this is called simple simple truss or plain truss.
Shall we take it as if we add any joint, two members are requirements?
Yeah, you are very right, and that's how we derive our formula also, that for any new joint we start with three joints and three members. We start with three joints and three members, and if we add any new joint, we have to add two more members. So we can go on doing this, and we can make internally stable structures. So if we have to find out the formula for such a structure, very correctly you have identified that for each additional joint we have to add two new members. So suppose there are J joints. If we have to find out the number of members in a plain truss or a stable structure, then it will be equal to 2 times j minus 3 plus 3. Why we have how we have derived this formula? It means that we count the number of joints, then we reduce three joints, these three joints from number j, so it will be j minus 3, okay, and j minus 3, and then the remaining joints we multiply it with 2, because this many members are required, and for these three we require 3 members, so I have added 3. So the formula for a stable structure is that m is equal to 2j minus 3 plus 3 in a plain pin jointed structure. So this will become 2j minus 3. This 3 will be cancelled out, and we can take 3 outside 2. So this will become 2j minus 3. Now again caution should be made that this is a necessary condition. but this is not a sufficient condition. A structure may be there where you can fulfill this condition, but this may not be internally stable. So finally it comes to the inspection of a structure. I will show. Take this truss only. Okay. I remove this member and add a member here. What will happen? The number of joints is same, the number of members are same, but this panel is not stable internally as we have seen earlier. So this is not internally stable structure. So merely fulfilling this formula is not sufficient. It is a necessary condition. If this is not fulfilled, you are certain that the structure is not stable. But if it is fulfilling, you cannot be sure that the structure is internally stable. So you have to see it and inspect it and verify it.
What is the verification criteria in this case?
Yeah, that's what I told you, that for there are 2-3 types of plain pin jointed structures. The one is simple frame, which I told you that by simple a rule of triangulation, that you draw a triangle and then go on adding joint and a point. So if any truss is there, so you can see you start with this triangle, then you add this point, add these two members, 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 this point connected with these two members, and finally this point connected with these two members. So this is a simple frame and this is stable because it follows the law of triangulation. So a simple inspection of this truss will tell you, of course you can derive the number of joints and number of members and you can check the formula. So I think that should come correct. If you count the number of joints, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 joints are there. So member should be 2j minus 3, that is equal to 2 into 10 minus 3. It becomes 17. Now start counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
Sir, the earlier structure you have drawn, apparently for a layman, for a student, the earlier structure also appears to be stable. In that case, how could we verify that this is a stable structure? In this, of course, you are an engineer.
No, I will tell you. Suppose in this structure only, if I remove this particular member, so you can see there is no triangle forming here. You see, these 4 points are there, so you can imagine that whatsoever is up to this point. Suppose I take a simple frame, this one, a square or rectangle. Now is it stable? It is not stable because this can form, this can deform in a shape of parallelogram, because you can rotate, this point can rotate, this point can rotate, this point can rotate. So basically this is not a stable structure. Now what we are seeing in this particular frame, suppose remove this member, we add it here, and we can add it one more even. But what is happening, that you see this part only. Whatever before this is a stable part, after this also a very rigid stable part, but this panel, this can deform because of you see these two parts are there. This part alone can move in this direction, so there is a flexibility in moving in this direction, and again this panel, it can deform in this shape. Till here this part was okay, so this straight line has remained here straight. Again this straight line will also remain straight with respect to this, and it can deform in this direction. The whole thing, the entire this thing can rotate at this point, again the entire this thing can rotate from this point, you see. So some readjustment will take place. So any panel in a shape of this square or rectangle form, there is no you can see that it can deform easily. So that is one thing that you can inspect. So as I said you that plane frames are of mostly 2-3 types. One is simple frame, which I said that if you follow the law of triangulation, you can draw a plane frame, and that is stable. If you join two plane frames, say this is ABC and this is DEF. If you join it at 3 points, 3 reaction components, it will also form a stable structure. This is called compound frame. You are adding 2 simple frames. Very common type of structure is say this is a frame again, this is a frame. So even if you can bring it together, and put it another, so you are joining it here by 3 linkages. You will say that I have joined it only 1 point here and there is only 1 linkage, but you see if you put a linkage here, so there is only axial force in this direction, so this is single linkage. But if you are joining 2 points, there are 2 reactions in these 2 directions, so this is equivalent to 2 linkages, and this is equivalent to 1 linkage. So if you join 2 simple trusses with the help of 3 linkages, this also becomes a stable structure, and that is called compound truss. So you can consult the books There are also complex type of frames. Say this is orthogonal frame, this is neither compound not simple, this is a complex type of frame. But the basic thing that with the help of inspection you can see that this is internally stable structure. If I remove this and add another member here, this part will become internally unstable. Is it clear? Now let us talk about statical determinacy and indeterminacy. Why do we calculate first of all statical indeterminacy? What is it? In fact, to analyze any structure, in a plane, say, you can write three equations, three equilibrium equations. Say a simple truss is there and three external supports which are required for its external stability are there at place. So you can write actually three equilibrium equations, and these three equilibrium equations are sigma fx is equal to 0, sigma fy is equal to 0, and sigma mz is equal to 0. These three equations are that the external forces, this is VA, HA, VB, and there are some loading on there may be some loading on the structure. So if you know the loads and to find out the different forces in the structure, you have three unknowns, external unknowns, HA, VA and VB. So first of all you have to find out these unknowns, and then only you go to the members and find out the internal forces in these members. So to find out these three components, you require three equilibrium equations, and these are available that in x direction you will take the equilibrium equation sigma fx is equal to 0. In y direction also you can write down the equation, and for rotation against sigma mz you can choose any point A or B or any other point, any other node, and you can take the moment of all the forces on the structure. Since the structure is in equilibrium, the moment of all the forces will be equal to 0. So through these three equations you can determine the external reactions, and then you can go on determining the internal reactions of the members. So that is why we call this is a determinate structure, and its statical indeterminacy is 0. But sometimes suppose we add another reaction here, then what will happen? This is point C, so another unknown force Vc will be coming, and you can write only 3 equations, and you cannot calculate the value of all the unknown forces. So then this structure becomes indeterminate. It doesn't mean that we cannot analyze this structure, it simply means that we cannot analyze the structure with the help of equilibrium equations only. Then we will have to take some help of some other equations, say compatibility equations, or finding out the deformations coming from these, and then balancing them. So then it becomes the structure becomes statically indeterminate. Now we will see that the indeterminacy, as I pointed it out, this can be external or internal also. Suppose we add another member here. So this member was not required earlier. You see, if this external support here at C is not here, and even this member is also not here, then we can easily find out the internal forces in all the members. We can start from any point from A. First we have externally obtained the value of HA and VA. So we can come here at point A, we can calculate the forces in AC and in this member. Since this is a plain truss, so only axial forces are there. So if we take the point A free body diagram, so there will be this is point A, VA, which is now known to us, HA is also known to us, there will be a force in this direction, say FAC, and there will be force in this direction, say FAD. Now again we can write 2 equations for this point in 2 orthogonal directions. One, sigma Fy is equal to 0 in vertical direction, and again sigma Fx is equal to 0 in horizontal direction. Again this is known, so FAC and FAD can be calculated by writing equations in 2 orthogonal directions. And if these 2 are known, again we come to this point. Since now this is known, these forces are known, so we can calculate the forces, internal reactions in these 2 members. We can come to this point C. This member is not here, so we can calculate the internal forces in this and this, because only 2 unknowns are there. These are known, so we can analyze this node also. Similarly, we can go on calculating and calculate the internal force in all the members. But as soon as I added this additional member, now I cannot go on calculating by this method, because after this point, now I cannot come to this point, because here the unknowns are 1, 2 and 3. So for any joint in a plane truss, you can only write 2 equations in 2 orthogonal direction, because it is not taking any moment. So moment will be 0, and you cannot write equation for moment. So for sigma Fx and sigma Fy, we can write 2 equations in 2 orthogonal directions, and here 3 unknowns are there, so we cannot calculate the forces, internal forces in these members. Again, if we come at this point, so this is known, but these three are not known. So again here 3 points are there. So after 1, 2, these 2 nodes, we cannot proceed further. Even if we start from this direction, we can calculate the force here, we can calculate the force here. After that, we cannot calculate the force because here 3 unknown will be there. So we cannot go at this point. Again at this point also 1, 2, 3 unknowns will be there. So we cannot move. So in these members, all these members, we cannot calculate the internal forces simply by equations of equilibrium. So it becomes a statically indeterminate structure. So we talk of a statically indeterminate structure again externally and internally. We see that the statical indeterminacy is it may be external, it may be internal. So now let us see how we calculate the statical indeterminacy.
Point of external or internal indeterminacy is not clear. How we say this is an internal indeterminacy or this is an external indeterminacy?
Yeah. I said that we can write 3 equations, equilibrium equations, to find out the external reactions. And for stability of any structure in a plane frame, there should be 3 external reactions. So I can say if we statical indeterminacy, we denote it by SE, external statical indeterminacy, it will be equal to RE minus 3. It means that external reaction, number of external reactions minus 3. If the number of external reactions are 3, we can write down 3 equations, so we can determine it. Then in that case, statical indeterminacy, external statical indeterminacy will be equal to 0. But if the number of reactions increases, external reaction, then external statical indeterminacy will also increase, and it will be equal to the difference between these two. So this is clear. Now when we come to internal statical indeterminacy, SI. So if suppose in a structure there are m numbers, this is a pin jointed structure. So what will be the unknown forces? That is, we call internal reactions. Since in a truss or in a pin jointed structure, there is only axial force. There will not be any shear force or bending moment in these elements. So there will be only axial force in these elements. So the number of internal reactions will be equal to m. And what should be the number for a stable frame? What should be the number of members? It should be equal to 2j minus 3. So if this member is equal to 2j minus 3, this becomes statical indeterminacy. If number of members are more, if I increase one more member, then one more unknown has been added here, and it will become statically indeterminate, as we have seen in the case. So this, because of the increase in member or increase in internal reaction, the indeterminacy has increased. That is called internal statical indeterminacy. And because of the increase in indeterminacy, because of the increase in external forces, that is called external statical indeterminacy. So this is the basic difference. Now in the next class we will take up again the pin jointed and rigid jointed structure separately, and we will calculate and take a number of cases, number of examples for a statical internal and external indeterminacy, and we will also see the kinematic indeterminacy in the next class. Thank you very much.
Thanks, sir.